Let's solve the following linear inequality. So what we'll do, we'll begin by first equating the expression within the modulus to 0. So that means we have x minus 1 equals to 0 and x minus 2 equals to 0, which gives us x equals to 1 and x equals to 2. We'll plot these 2 points on a real number line. So we have a real number line which contains all the values of x. Here we will consider x equals to 1 and x equals to 2 on that number line, and we see that this immediately divides the number line into 3 regions. We have region 1, region 2 and region 3. So what we'll do, we'll try to study the behavior of this particular linear inequality in each of the 3 regions. Now before doing that, so here region 1 refers to all the values of x which is greater than negative infinity but less than 1. Number 2, we have x greater than or equals to 1. So here we are including the value of 1, but is going to be less than 2. So here we are excluding 2. And 3 will be all the values of x which is greater than or equals to 2, but less than infinity. Right. Now what we'll do, we'll try to study the behavior of this particular inequality in each of the 3 regions one by one. So let's begin. So we are now in region number 1. So in region number 1, we have x lying between negative infinity and 1. So that means absolute value of x minus 1. So that's going to be negative of x minus 1, which is simply 1 minus x. Also, absolute value of x minus 2, that will be equals to negative of x minus 2, or simply 2 minus x. That means now we can rewrite our inequality as 1 minus x plus 2 minus x. So that's greater than or equals to 4. This gives us 3 minus 2x greater than or equals to 4. We have negative 2x transposing 3 to the right hand side gives us 4 minus 3, which is 1. Now what we'll do, we'll divide both sides with negative 2 because we want to make the coefficient of x positive 1. But since negative 2 is a 2 is a negative number, so that means the sign of the inequality flips, and this gives us x less than or equals to negative half. And what we'll do, on a number line, we will consider that we are in this particular region, negative infinity to positive 1, and we're getting that x is less than or equals to negative half. So here we'll be having negative half. So we have to consider all the values of x lying to the left of x equals to negative half. So this means this is the only common region which satisfies both x less than equals to negative half and x lying between negative infinity and 1. From case number 1, we obtain that x is greater than negative infinity, but this is less than or equals to half. So this is from case number 1. Let's move on to the second case. So in region number 2, x is greater than or equals to 1 but less than 2. In this region, absolute value of x minus 1 will be x minus 1 is going to be positive, whereas absolute value of x minus 2 will be equals to negative of x minus 2, which is 2 minus x. We can now rewrite the inequality as x minus 1 plus 2 minus x. So this is going to be greater than or equals to 4. So here negative x and positive x gets cancelled. So we have negative 1. So we have 1 is greater than or equals to 4. But this is not true. So that means we will get no solution for region number 2. Now let's go to the final region. And in final region, we have x greater than or equals to 2. So here absolute value of x minus 1 will be equals to x minus 1. Absolute value of x minus 2 will be equals to x minus 2, such that our inequality now becomes x minus 1 plus x minus 2 greater than or equals to 4. So we have 2x minus 3 greater than or equals to 4. 2x greater than or equals to 3 plus 4. We have transposed 3 to the right hand side to get 2x greater than or equals to 7, or simply x greater than or equals to 7 over 2. We've divided both sides with positive 2, and this does not affect the sign of inequality. So here we started out with the condition that x must be greater than or equals to 2, and we have obtained that x is greater than or equals to 7 over 2. So this will be 7 over 2. So here x is greater than or equals to 7 over 2. So that means our common solution will be x belonging to 7 over 2 to infinity. So here 7 over 2 is included. It's a part of the solution. So we'll use a closed interval. Right. So that means in case number 1, we obtained the case that x less than or equals to negative half. Case number 2, we didn't get any solution. There was no solution. And in case number 3, we obtain x to be greater than or equals to 7 over 2. Now, if we combine these three cases, so we only have to combine 1 and 3. 2 does not make any sense. So that means x belongs to the interval negative infinity to negative half union. So half is a part of the solution. I'll have to use a closed interval union 7 over 2 to positive infinity. So this is a solution to the given linear inequality.